No? Yeah. Professor, you can unmute yourself now. You can unmute yourself.
Okay, thank you, sir. Good morning, everybody. Thank you for this opportunity, Prof. We really appreciate your consistency. May Allah, hello.
Hello, we are with you. We are hearing you. We can hear you.
We appreciate your consistency. May Allah be with you. Thank you very much.
Amen. Thank you.
Yes, this the one we talked about today, the one regarding the application examples of the precision farming, livestock farming.
Yeah.
So when I saw this 3D camera, for the 3D camera, in my own assessment, I think we can use it for every other one except automated weight tracking. Yeah. I'm wondering how the 3D camera can actually help us track animals' weight. So that's the first question.
Okay.
The second one is like a comment. You mentioned the fact that the practice of raising animals in different cages, is being discouraged by animal rights people. Yes. In fact, it's actually what we call organic agriculture movement. They are the one really promoting it. The organic agriculture want to take us closer to nature than away from it. And there are certain interventions human beings are carrying out, in organic in agricultural space that are deemed not good, too good. So one of it is that isolating animals is not good. They should rather be allowed to flow together in the same space and then be fit together like that. Though, capitalism will tell the farm owner that it's more expensive to feed animal that way than feeding animal individually inside cages. But that is why organic animals that are produced organically, and even crops that are produced organically, are much more expensive than the one that are produced via conventional agricultural practices. So I am looking at a time when we are going to define or come up with machine learning models and activities that will also assist this particular trend, because as it were, the trend is not attractive because everybody that goes into agriculture go there because of money, optimization of capital, and currently that is not being achieved. So it is making organic produce more expensive. That means it is restricting it to only those who can afford it. So we are thinking that maybe at a point in time, we might have some machine learning models that will also assist organic agricultural practices and make them more cost effective, and then be available to everybody that need them. Yeah. Thank you, Prof.
Thank you very much, Professor, for the very thought-provoking contribution. That is really talking to somebody who's a professor of, I don't know the specific specialization for professor of agriculture from the Premier University of Ibadan. Thank you very much, sir. Thank you for the very nice comments. Hopefully we all gain from it. Yeah, we have been reading about such things and the promotion of that. And sincerely, with my own little practice and this very small subsistence one of recent, I think I'm also supporting that idea that the animal should be allowed to roam. They are social beings. They also need to interact with themselves rather than putting them in a cage just to eat and produce. No socialization, no interaction. So we hope we'll be there. I want to believe with careful deployment of AI machine learning, it can go a long way to actually cut some of the cost that we are actually afraid of. before. We can cut the cost of those things that are associated with it as stated. Now, to go to the question of my professor, which is if there's anything on, the least expected is how can 3D camera be used to track animal weight? That is it, Prof. And that is how AI make what we think to be impossible to be possible. Actually, yeah. How is 3D camera related to weight of an animal? Yes, it is possible. And actually, it's one of the areas that is really gaining a lot of research and grant. The way it works is this. It works by capturing the 3D images of the animal and then using computer algorithms and software to analyze and capture data and then estimate the animal's weight. You see, it's in AI is just bring the data. That's why if you look at the beginning of our lecture, we said, let the data speak. Once there's data, then we can make use of it to estimate for the unknowns. So once the 3D image capture, it's captured the positioning. 3D advantage of 3D, you can capture it from different angle. Okay, yeah. So the data extraction follows. You extract key features like body dimension, length, width, height, and potential other traits that could be useful. By the way, my prof issue, I want to tell you that we already have systems that can actually, by just looking at someone's face, taking some measurement of his fingers, then we can be able to predict the weight of this person based on the weight of previous people we have seen before. These are some of the impossibility that is becoming possible with the use of AI. And that is why we consistently saying that we can no longer ignore AI. Yes, 3D is like picture. How does that relate to weight? But once we take it and we take the necessary dimension of the animal, then using the previous data we have, animal with such dimension, this is the kind of weight they brought out. With enough training of the model, definitely it will be able to extrapolate to the unseen cases of the data. So once the data is extracted, we get the necessary features that are relevant, or the potential traits that can determine weight estimation. They'll be taken care of during the extraction of data from the 3D camera. After that, we move to the weight estimation stage, where we are going to use the model to predict the animal's weight. So it could be as simple as k-nearest neighbor we'll be discussing if we have the data. Once the data is extracted from the camera, from 3D camera, then we can take it to any algorithm to use it. But if you are able to use deep learning, it has the capability of automatically extracting the feature itself. That is if you need a real-time system to warn you something is going on with your animal immediately. So it is a possibility, my prof, and that just take the camera, take the 3D images, extract the feature, the weight, and whatever trait that can be extracted from the picture. Based on previous data, we'll be able to estimate the weight of the animal. Yeah, because ordinarily, the only way to estimate weight is to bring them on the weigh machine. So when you have like 1,000 animals, 10,000 animals, how do you bring all of them to the weighing machine? No. So with a camera, we take the 3D image, we take it back to analysis. AI system will be able to tell us this is the weight of the animal. And if you implement a real-time one with deep learning, while the animal is roaming, you'll be alerting that animal is getting overweight. Real-time monitoring of the animal weight. We don't need to physically take the animal onto the weighing machine. So it's a possibility, my dear professor. Thank you very much. I hope I answer your question, sir. Okay.
Yeah,
so
very well, Prof. Very well. Thank you very much.
Yes. We have Folasheye Elijah. You have the floor. You can unmute yourself. Folasheye Elijah. Can see your hands up.
Okay, sir. Thank you, sir. Good day, everyone. Though this is my first time on this and I'm a computer science student, sir. I'm Mofala Falashe Elijah by name, sir.
Okay.
Sir, okay, sir. Sir, you listening, sir?
Yeah, I'm with you. You are welcome, Elijah.
Okay, sir. Okay, sir. Thank you, sir. So I'm actually asking the question in regard to the fact that to using environmental and historical data, historical data to actually predict for modeling. I'm focusing on that one, sir.
Yeah.
Sir, can you hear me?
Yes, I'm with you. Go ahead.
Okay, sir. My question now is that if a firm or an agricultural maybe company or organization wanted to actually produce a model for to actually stimulate and know all the symptoms in order for them to actually take a proactive step before anything happens. And so we know that we have different species of poultry bird. So is a single maybe a model enough for this course? Because I think I'm just thinking because in my own perspective that there may be different symptoms for different poultry birds, sir. So is there any how we can actually produce a model that can actually generalize all those poultry birds?
Okay, thank you very much, Mr. Elijah, for that nice question and showing that you follow the lecture very well and for thinking ahead of how can this be implemented. Yes, especially you are in computer science, so the world needs you to come and build solution for them. People need this thing urgently. However, for the question you just posed, yeah, generalization is a big issue. So we start from simple to complicated one. So you first of all build a model which is using data. For example, you want to be able to predict this animal will be sick before it became a big issue. Because generally disease stay in the body for days or weeks before it starts coming out as symptom. The moment the symptoms start coming, it may be late, especially chronic disease. That is why we propose proactive medicine for both human beings and animals. That while an animal is still roaming, behaving as if everything is okay, some diseases are already in the body. So can we predict that at that stage when there is no symptoms? So the ordinary vitamins might actually be what it needs to be able to boost back the immunity and subdue the disease that is growing. However, when you build to a specific trait of animal. Yes, this is one of the limitations of AI. You don't build for everything. For example, if you build to predict diabetes for human being, you can't use the same diabetes prediction to predict hypertension. No, you have to build another one. Now, for the same disease, for the same group of evil human being, if you build to predict diabetes disease for people from Nigeria, for example, it may not work for someone from another country because what they are eating there is different. Their genetic makeup may be different. So we may need to bring, this is what we call heterogeneous database predictive solution. We may need to bring data. If you really need a system that can work for everything, then it's very tough to do that, by the way, but we are working on it and hoping it will become a reality. You bring data set from different places, merge them together, use them to train and test. You know, we're having different characteristics now mixed together, divide, and then you do it separate. At the end of the day, it may work. It's very challenging. Heterogeneous data modeling is very challenging, but it is not impossible. But you have to have enough data set. And then we recommend for you to go ensemble modeling. A single model cannot capture those complicated relationships. You have characteristics from Nigeria, characteristics from US, characteristics from Saudi Arabia, people from different backgrounds. You want to build a single model that will be able to identify a particular disease in their animal or in their human being. This is very tough. And that is the next stage we are moving. And that is based on the performance of Ensemble, I believe it is a possibility. Though the prospect is still very young, but it's a possibility. Because Ensemble has that capability of combining the power of multiple models to make a joint decision. You see? So, and that's going to be a big game changer. However, for the start, there's no harm in doing. If you have the data set, model it for a particular breed, do for another second breed. Now try to bring the data together. This breed and this breed, mix their data together, train and test, see if it's going to work. If another way is I have breed A data, breed B data, breed C data, I can use breed A and B to train and breed C to test. And I can also mix the entire data together and then divide into training and testing and then build the model. Until we do that, always remember, let the data speak. The data you get will determine the possibility of such issue. But to be frank with you, it's going to be very tough. But it is not impossible. We started doing that in oil and gas. Usually when you have oil well 1, oil well 2, oil well 3, you train and test using oil well 1 to determine oil well 1. You don't use it for 2. But I now said, why can't we merge this well together, data, divide them so that we can use only one model for the entire wells at the rate of 80% now. So to me, it's not bad for a start. So it's a possibility, but it needs work. And I recommend Ensemble model for such complicated modeling. I hope that is clear, Mr. Elijah. Thank you for the question.
Thank you, Prof. Thank you, sir. Thank you very much, sir. I really appreciate it.
You're welcome. So we have 1 or 2 questions more. It's already time. Just thanks, Prof, for the wonderful presentation. Is there any minimum number of size of animals for making prediction with respect to making cases for feed intake, weight gain, milk yield, as far as AI is concerned? Well, there's no minimum number of data, but the more, the better. So let the data speak. So once you have very few data set, I recommend support vector machine for you. After you try k-nearest neighbor, whatever you get, compare with support vector machine. Support vector machine is a statistical base. It has its own background in statistical learning theory. It has that some unique capability of working comfortably in the presence of fewer data sets. So that's why I recommend it. However, the more the data you have, the better. But if that's the only thing you have, don't give up. No amount of data is too small to try out. If really small, then you use the cross-validation approach to check your data. However, the more data we can get, the better for us. So this is my advice in this respect. About the issue on behavioral monitoring, can it solve the issue on extensive farming? Where that's another, perhaps a professional agricultural expert. So it depends on what you define as extensive farming. So on behavioral monitoring, so definitely can solve a lot of problem on farming if you're able to monitor the behavior of animal. So you will know animals that are aggressive and the likes. However, so the questioner, if you can explain to me, what do you mean by extensive farming? What do you intend by extensive farming? So we wait for you to clarify your question. Another questioner say, thank you so much, Prof, for the wonderful lecture. Please, I'm sorry, my question is not pertaining to agriculture. You are welcome, that's okay. For ML model with training accuracy of 98 and testing accuracy of 88, is this model overfitting? No, we can't consider 98% training and 88% testing as overfitting. No, it's okay. Before you can talk of overfitting, the testing set will be like maybe 40, 50. Even 67 sometimes, we don't say it's overfitting. You see, so because the moment you start getting 100% your training, then we start fearing overfitting. So this is a good result. 98% for training and 88% for testing. Even 75, 70 is still a good one. But you can go back and do your parameter optimization or use another algorithm, starting from simple to the complex. However, 98% training accuracy and 88% testing accuracy is not considered to be overfitting. It's a good model. Yeah. Another question, how can we reduce the error that can arise from AI camera while tracking the livestock behavior where AI wrongly took a behavioral for others? Well, that is why some of these systems we need a wearable system. Some of the animal will have wearable sensors because animals move from place to place. If you take a 3D video of an animal, how are we going to know that this is the animal we have taken the video? because they can be very similar to themselves. So there will be a wearable sensor that tag and identify the animal easily. So whatever prediction you are making for one animal, you cannot make mistake for the other animal because there's a tag on it and it's monitored automatically. The sensor it's connected to the system. You know that is animal sensor 001. It's predicted that it's having overweight. We have to look into it. And there are sensor monitoring that can locate it for you. In the midst of hundreds of thousands of animals, you can locate where that animal is because there's a tag. Okay? There's a tag. Something will detect it and will make noise that this is the position of the animal. We have positioning system and also for that technology that can be deployed. That's why we call it precision agriculture. A lot of things are involved. Finance is also financially very costly. Is it possible to carry out hybrid model from traditional model and machine learning model result on weaker environment? Yes, we've described that. You can check out Ensemble, especially Ensemble. We have several videos on how to do Ensemble in weaker environment. You can check out the videos on our YouTube channel. You can do Ensemble in Weka. You can do a lot of things in Weka if you are not comfortable with Python or programming. Even you can do deep learning on Weka. So thank you. Extensive animal farming involves raising livestock over large areas, often in free range or pasture-based system. This approach prioritizes animal welfare and natural behavior. Okay, thank you very much, Mr. Ugwoke Kenneth, for the clarification. It's clear to me now. Yeah, what do you mean by extensive farming? Yeah, it is possible. The behavioral, the monitoring is still possible, but however, like the previous questioner raised, there have to be a way of identifying the animal. They may have to have tag on their body. So that sense they can be able to know which animal is this. So that when you predict that this animal, in fact, in those extensive farming, we need a lot of AI system. We want to know an animal that may be in trouble in the next few minutes so that the herders can come to their rescue. It's possible. You can monitor animal and know animal that may be in trouble. Prediction will tell you animal so, tag so. Somebody will just enter the tag into the system and then the sensor will indicate where that animal is located presently and they can go there and rescue the animal. See, there are some they even do recently whereby an animal will be made to wear some special device that prevent them from grazing beyond where you want them to graze. It creates an unseen barrier, but the animal feel that there's a barrier already. I've freed the barrier. Because of the sensor it's wearing. It cannot go beyond where you want him to graze. Maybe you are practicing rotational grazing. You graze here to this week. Next week you are going to another place so that this place can germinate again. There's a way you can control your animal that they will not be able to go to where you don't want them to go to. So precision agriculture have really introduced a lot of possibilities that we thought initially that was not possible. So I believe these are some of the questions we have for the day. Thank you very much all for listening. So believe that's what we're going to have for that. Thank you very much all. And please do encourage and spread the message. So as much as possible people, we want them to benefit from this weekly program so that we can all be AI aware and then see how far we can go in utilizing it towards solving our environment and also benefiting humanity. So thank you very much. Thank you very much.
Thank you, Prof.
You're welcome, sir.